Hopefully you feel that way when I get done. Everybody can hear me okay? Clear in the back? Okay, I'll try to keep my voice up. If I start getting quiet, let me know. If the screen, you can't see the screen very well, let me know too, because we can turn some lights off as well. Tonight I'm going to talk about how the Ice Age floods changed the course of the Palouse River. This is one of the many stories within the floodscape of the Pacific Northwest. We're going to see that there are, we'll see how everything works here now. Okay. This is so much fun with technical stuff. Let's try that one. There we go. So to keep me on track, we're going to kind of look at about three main things. First of all, we're going to look at the two main ingredients that make up our area here, which is basalt and loess. Give you a little bit of information on that. We'll look at a couple small things too. And we're going to look at the geography of this area, mainly the middle and lower part of the Cheney-Palouse Scabland Tract. Now, I think a lot of you are familiar with the Ice Age floods, so I don't have to go into the big story of how all this happened. I can kind of go through that. Then we're going to look at the main part, which is the capture of the Palouse River. So the basalt. The rock that makes up our area here is mostly the Columbia River basalt. These basalt floods came out millions of years ago, started down in the, down mostly in this area, northeast Oregon, southeast Washington, along the Idaho border there. And these weren't volcanoes like we normally think of, big cones like we're there. These were fissure eruptions like we've seen recently up in Iceland and also in Hawaii, where we have this long crack and the lava comes out and flows out both directions. Some of these went out as far as the Pacific Ocean. So these were monster eruptions that happened over many, many millions of years. And the first ones were the biggest ones, and they filled in the Columbia Basin.
Keep your military voice up.
Okay. What's interesting about this, we're on the North American plate, as you probably know, and we're slowly drifting to the west and rotating just a little bit. And at that time, there was a hot spot underneath that spot, kind of like Hawaii is today, where there's a hot spot and the crust is moving across and you get islands forming under that hot spot. Well, we had a hot spot here, but our plate was moving over that hot spot. Today, that hot spot is underneath Yellowstone. Okay? Yellowstone. So that's where our next, or maybe one of our next supervolcano takes off. There's about 10 or 12 around the world, so that one probably gets the most attention, but it may not be the next one.
So that underneath is flowing to the east, but the North American plate is flowing to the west.
The hot spot stays in the same spot. We float over it. We drift over it. This is an interesting shot here. This is actually a cross-section of one of those fissures where the lava came up. And you see the color of that and the color going out both directions. So we have one flow below that. We got this flow that came up and spread out both sides, then another flow over the top. If you talk to any of the geologists that are in here, I know there's some geologists, they'll probably divide basalt flows up into what, about 7 layers or 9 layers? I'm going to make it easy for us. We're going to go with 2. The 2 main ones. And they are, if we split those up, the top part of the flow is called entablature, which you may be familiar with that term. The lower part is called the colonnade. Colonnade is where we see these nice columns. Okay? Entablature is up on top. These develop because of different cooling rates. As these lava flows come out, they cool from the top down pretty rapidly. They cool from the bottom up much slower. As they've got that slower time, they have time to form these really nice columns. I was on a field trip down in Oregon a few years ago, and the geologists there kind of explained that these lava flows have a psychological problem when they come out. Kind of like HAL the computer. They have to do 2 things. One, because they're hot and they're cooling down, they must take up less space. And the molecule's saying we must hold on together. And they can't do both. If they couldn't hold on, if they didn't mind about holding on, they'd probably just end up with round columns all the way up. But because they have to hold on, they end up with these polygonal shapes in our columns. If you have questions, I kind of like to keep this informed. If you got questions along the way, just holler them out. So we spread, whoops, let's go back. So we go back. So now we've got one flow, 2, 3, 4, 5. That's about a 200-foot height from bottom to top, which matches our normal 40 feet per flow average in this area. Now, this is the lower Palouse Canyon, by the way.
Well, the flows have...
They're all happening at different times. The first ones came out bigger and more often, and then as time went on, they slowed down and were smaller. In fact, some of the very last small ones up in the Winona area and some of that area, they're more like what we saw in Hawaii a few years ago when they came out and kind of flowed down and just formed kind of a chute going down, and they cooled differently. That's another subject. A geologist should talk to you about that, not me. Another thing we have are intersedimentary beds. This is about sometimes between one flow and the next, we'd have many, many years, and soils would form, plants would grow, forests would grow, lakes and rivers would flow across. And we've had that. We've got these sedimentary beds in between the lava flows. And this is one right down here. You can see the columns right up above and down below. This is Chad Pritchard, by the way. A lot of you know him from Eastern. This intersedimentary bed is in the Palouse Canyon, about 200 yards up from Palouse Falls. Okay, so you find these throughout the Columbia Basin. You find these intersedimentary beds, some much bigger than this. What's interesting to me is right where those two gentlemen are standing, if you walk right where they're at and look straight up the side of the cliff, this is what you see. Yeah. Here's your columns. Here's the entablature. And you notice you've got the same type of structure. You've got that polygonal shape. Instead of those big structures like this, now you got all these like spaghetti-like things going out and intertwining and kind of connecting together. They cool differently. Our other main ingredient here is loess. And this is this windblown soil that we have, making up our wonderful Palouse soil. This is blown in from somewhere else. Does this still happen? Yes, it does. How many meteorology nerds are here like me? All us meteorologists in here? When a warm front comes in, you got your land here, warm front comes in kind of like this. Not very dramatic. But when a cold front comes in, it comes in like a bulldozer. That cold, dense air stays right down on the ground and it forwards up like this. And as it comes forward, it forces that warm air up over the top of the cold air, raising up all that dirt. And boy, you get that nice shape right there as that thing comes in.
Far down under the dirt is the basalt?
It varies how far under the dirt is basalt. Some places there's very little dirt where the floods came through and took it out. Other places we've got depths up to over 200 feet.
Oh.
Another thing that we have in here from time to time are what we call erratics. Now that's not the young lady up there on the rock. It is the rock itself. I've got to make clear sense of that. This is actually granite, and an erratic is any rock that is in your area which is not native to your area. And the question is, then how did you bring that thing in here? From Montana or northern Idaho, where it originated? Well, the Ice Age floods did that. Came in on a big iceberg and then got stranded.
Is that the same thing as a country rock?
I've never heard of the term country rock. I always learn something new. Thank you.
I don't know if that's accurate.
This lady in 2020, she was a graduate student from the University of Massachusetts, and she was doing her doctorate on measuring the time when this granite was deposited. Now, I'm not a geologist, so I'm not going to give you a real good explanation, but apparently when a rock gets, like granite gets dropped, it immediately gets exposed to cosmic radiation from all directions. And that's very constant, and it changes the outer edge of that granite into something different at a very specific rate. And so she was out here taking samples off the outer end of these granite erratics from Grand Coulee. This one is near Cow Creek, kind of southeast of Ritzville, and other ones down at Lyons Ferry. She was taking all these samples, and so I helped her find these things, and she went out there and she was taking all these samples. Take them back to the lab, you powder them up, look at them send them to the lab, and then they can tell you where it's at, and by that they can say, okay, this was exposed X many years ago. And by doing that, over all this area, they start understanding which floods came, the last floods that came through this area compared to the last floods that went through another area. This is way over my level of understanding. I'll admit that, but it's pretty neat stuff. So let's look at the geography for our area. You're close to this area, so we're just going to throw in some of our areas here. You all know Sprague Lake up here, Sprague, Ritzville, Washtucna, that's where I'm from. Hooper, Kahlotus, some of those may not be quite as familiar to you, but this is all part of that lower part of the Cheney-Palouse Scabland tract. So we'll throw those two lakes in there. Most of you have been over Sprague Lake. Have you ever been out to Rock Lake, most of you? So you know where it is, yep. So the Palouse River flows in from the east there and cuts down across to the Snake River. However, okay, and so that's within, I'm going to kind of put in yellow, that's the outer edge of the Cheney-Palouse Scabland tract that we call that area. I'm going to put in red there, that's where the Palouse River used to flow before the floods came through. It flowed down through present-day Washtucna, Kahlotus, Connell, Mesa, Eltopia, and entered the Columbia River down by the Pasco Airport. Okay, so our question is, how is it possible for that thing to change course? Why would it do that? I mean, it had a nice little valley that was already running down. Now, it took two things to make that happen. And obviously, we're talking about a lot of water for one of them. But I'm going to show you that water enough wasn't enough. We had to have something else going on. And we're going to get to that.
What's the blue?
The blue line is the Palouse River.
Existing one.
Right here, yep.
Okay.
That's existing Palouse River today.
Right. What was it originally? That's the correct.
Well, in our lifetime, that's where it was. But it used to go down where the red line is.
That's amazing. So it only changed course sort of south of Washtucna?
Yeah, it shortened its course by about 50 miles. And we're going to take a close-up look down there as we go further into the program. Okay, so most of this is what you know already, but we'll just go over it just in case we got some new people here that aren't familiar with the floods. Okay, so you got the map of the floods during the last part of the last glacial period, about 18,000 years ago. Enough of that ice up there in Canada finally started coming down through north-south valleys. One lobe came down through the Purcell Trench to where Lake Pend Oreille is today and blocked up and dammed up the Clark Fork River, forming Glacial Lake Missoula, which is all this purple stuff. A little bit later, another lobe came down through the Okanagan onto the Waterville Plateau and finally stopped about where present-day Grand Coulee Dam is, and it blocked up another lake called Lake Columbia, Glacial Lake Columbia. Glacial Lake Missoula had no outlet. It just kept getting bigger and bigger and bigger. Glacial Lake Columbia, it got up to a certain height and it started spilling out to the south and basically started cutting out the Grand Coulee. Okay. So that black line over there, that's kind of the Grand Coulee area, which took water through there. In the middle, we have what they call the Tilford Crab Creek Scabland Tract, which takes kind of the area of Davenport, Wilbur, Odessa, that tract that kind of goes through there. Then the one we're really going to look at is what they call the Palouse Scabland Tract, which I think most of you are familiar with. That was the easternmost tract that water spilled out of glacial Lake Columbia. So that first area, that's what we're going to look at, that part right in there. And this, but first, this is what one person thinks glacial Lake Columbia may have looked like. There's the ice dam. That's approximately 2,500 feet thick. Thick, half a mile. The lake at this point is 2,000 feet deep.
Lake Missoula or Lake Columbia?
Lake Missoula. Lake Missoula, they figured, had around 500 cubic miles in it at its peak. Up at Missoula, the water's about 750 feet deep. They now know that dam failed catastrophically, and all that water rushed out of there probably in around 48 hours, most of it. And when it came out, there was no place to go but other down the Spokane Valley and down across what we call the Channel Scablands. And of course, once the ice got blown out of there, it advanced again, formed another Lake Missoula. Now, you can get into a lot of arguments with geologists as to how many there were. The last number I heard from the Friends of the Pleistocene, they were looking at 81. But I've heard as many as over 100, and other people we talked to, there were a lot less. Okay. The first one was probably about 18,000 to 14,000 years ago. 18,000 to 14,000. And again, people look at that and maybe 13,500, there's... Floods have a great way of destroying evidence of earlier floods. The story is real simple, but the details are just mind-boggling. Roughly about 14,000 years ago. Geologically, that's just a blink of the eye, right?
So the ice would break, the water would flow, a new lake would form, ice would build up.
New lake, and repeat. They figured when these first big ones were going maybe 120 years in between, when they got down to the later parts, this right at the end of this last glacial period, the ice isn't advancing as quickly. There's warming coming up, so the water is melting, or ice is melting faster, so the lake fills up faster. And they figure those smaller floods, maybe even the last 40, I heard, may not even made it to Portland. They just went out and kind of fizzled out as they went out. But the first ones were really big. You got a time machine? I think we'd all like to know. When we get all done, I got a little bonus for you, and I'll show you some evidence of other stuff, I don't want to blow your mind up all at once here. I want to take it in general little bits, okay? So we'll go back to our map here and we'll throw our stuff in, and you would think that most of the water coming down through the Cheney-Spokane Tract would either follow down through the Cow Creek side or it would go down through the Rock Creek side. But you know what? There's so much water coming down the Cow Creek side that some of it is flowing over into the Rock Creek side. There's so much water coming down the Rock Street side, it's overflowing back into the Cow Creek side. In fact, there's water going all over the place. In fact, I just drew in a blue line up there in the top. That's Crab Creek. That other Scabland Tract area, that middle one. There's so much water coming down there that some of it is spilling into the Cheney-Spokane Tract. And there's so much flood water in our tract that some of it is spilling back out and heading east in several places, and finally enters the Quincy Basin above Othello, between Othello and Moses Lake. Water everywhere. Okay? And of course, we still have water, hopefully going down the Palouse River Valley there. So what have I got next here? Not only do we have water coming out there, but we also have water spilling across down here at Kahlotus, cutting out Devil's Canyon. And I'll show you some pictures of that here in a little bit.
But notice there's no water flowing west from Ritzville. Is that because Ritzville was up higher?
Well, Ritzville, there's actually at Ritzville right here, water came down Patapsco. There's a coulee right there that actually comes down and joins Paha coulee along 395, and it joins up with this water down here in the Lynn coulee. Like I say, there's water more places than I show up here. So we're going to start our journey up here in the Rock Creek area. So we got water coming down Rock Creek and entering the Palouse River. But there's so much water coming down Rock Creek coulee here that some of that's spilling over and cutting out through the Palouse Hills there in 4 different spots, 4 different coulees. Over in Whitman County, they don't call them coulees, they call them coves and draws. That's a whole nother talk that I've given on coulees, so we won't go there tonight. So we're going to take a close look at these 4 spillover coulees. Big Cove is the one furthest to the east, and it's the furthest east that water entered into the Palouse River. When Big Cove and Little Cove both came in to the Palouse River Valley, they came over and then down into the valley. And then they came down, they started undercutting and creating a retreating waterfall going up. The undercut, slough off, they keep going upstream. That's what these 2 are. This is Little Cove looking down. Palouse River flows left to right here. And they're pretty cute, pretty neat coulees there. Further over, you've got Mason Draw, which is kind of your normal shaped coulee. And western one is Texas Draw. And this coulee is pretty good size as you can look across there. I always ask the question of my professor like Gene Keever, how is it possible that you get this erosion through this rock, but that Palouse soil off to the side, that should just wash away really quick, right? And so he explained it to me. And he said it's a term called turbicity. As that water goes through or by that less soil is made up of little tiny particles. And so when that water comes by, it just flows. But when it gets down to that rock, which is brittle, and you start plucking out rocks out of that, then it starts getting really turbid. And the more turbid it is, the more energy it has. The more energy it has, the more rocks it pulls out. And pretty soon all that energy is forcing that coulee to go down, eroding down, rather than eroding out to the sides. I thought it was pretty cool. It answered my question anyway. And I learned a new word. We go over about 5 miles down from Colfax on the Palouse River. We find the Palouse River just this nice meandering, stream, just where everything looks normal here. In the distance, we've got Steptoe Butte, and it's just a nice horseshoe. It's just a beautiful place there. We go down about another 10 miles, and it's starting to change a little bit. Now we've got kind of a flat area here, looking up the Palouse River. The reason we got this flat area is as the floodwaters came down through the Cheney-Palouse Scabland Tract, they got up so high they started back flushing up some of these tributaries coming in, which was the Palouse River. And as they back flushed up there, they deposited dirt and they deposited flat. And so we start seeing these flat areas next to the river. Let's go down about 8 more miles. Things change radically now. This is where the Palouse River and the Rock Creek come together, looking upstream. And now we have what we call underfit streams. Now we have 2 bodies of water there. They're too small to make the channels that they are in. They're called underfit streams. Remember I showed you Texas draw here just a little bit ago? Can you see it over there on the horizon? Can you spot that? Let me help you out. Right there. That coulee looks so big is now just dwarfed by all this water coming through. Okay. We go down to ground level and look down the river at the confluence of these two. And we throw in that picture from up above. We can see quite the difference between the floodscape and the non-floodscape. Off in the distance, there's a little bit of Palouse Hill shining up there. That's about 4 miles back from the edge of the coulee or valley, whatever you want to call it here. That water coming down at this point, there's no way that Palouse River Valley can contain that water anymore. And it floods out here at least 4 miles to the east and actually around the other side of that. And then that goes down through La Crosse. So we've looked at that area. Now we're going to go down to the Cow Creek area, the lower part of the Cow Creek area. We've got water coming down Cow Creek. Cow Creek comes out of Sprague Lake, by the way. And a little footnote here. Originally, Sprague Lake was called Cow Lake. And the city fathers of Sprague thought this isn't going to be a very good way to attract people to our town. So they changed the name to Sprague Lake. Cow Creek, they didn't change its name. Okay, so we got the water coming down here. And there is water coming down the Palouse River as well into Hooper. And okay, there we go. There's so much water coming down Cow Creek in this area that it spills out to the west or an area called Rattlesnake Flats, which is a fairly flat area, but this comes out. And once it gets out there so far, it spills down over a monoclinal area. Monocline is a single fold that goes down. And it's called the Washtucna monocline from literature way back when. But it flows down through here into Washtucna. This area from here to Cow Creek is about 3-4 miles. This upper rim is about 3.5 miles. And the drop between the top down to the bottom is about 800 feet in about 6 miles. And the hydrologists have estimated the water coming down through the Staircase Rapids is flowing at least 70 miles per hour. There's so much water coming here that not only here, but also further cuts out another coulee over here called Collier Coulee. And that's kind of interesting because it comes down, it actually splits into two. Normal drainage doesn't do that. Flood drainage splits and works its way around. And there's other places where water spills across the divide out there, cut some other coulees. And of course, we got all this water coming down from the Rock Creek side. They have estimated, not me, scientists have estimated that right here coming down through the Cow Creek area there would be equivalent to over 200 Columbia rivers today. Now, I haven't heard any estimates of what it is coming down the Rock Creek side, Rock Creek Palouse River side, but if you look at the landscape, you kind of figure it's got to be about the same amount. Up there at the Cheney-Palouse Scabland tract at the greatest width is about 26 miles wide. Now it's all getting funneled down into this one little area at poor little Hooper down here. So there we are. We're about 26 miles across up here at its widest. And now we're, forcing all that into this one area. It comes down and it has to go across. Here it comes down Cow Creek and Rock Creek, Palouse River. Continues on down the old Palouse River Valley. Meets up with water coming down through the Staircase Rapids. But most of it, a lot of it, gets forced across the divide between the Palouse River Valley, the old river valley, and the Snake River Valley down here. This tract across here, I call it the Palouse Snake River Spillway. It's 10 miles across here. Gene Keever kind of describes it as if you were standing there, Hooper, with a super fire hose. Super duper fire hose. And you're just flushing that water across the divide. And there's some other place where water's spilling across and doing its thing. Okay. We look up Cow Creek. This is the Palouse River flows right down where these trees are right now, right down through here. Okay. Hooper is just off to our left, and we're looking up Cow Creek. So imagine 200 Columbia rivers coming down right there. We're going back up a little bit. That last picture I showed you was just that little bit right there. We see Palouse Scarp over on this side, the edge of the Palouse, the edge of the Palouse over here. That distance is 4 miles across there. Now, let's go up on the divide itself. We're looking up the east side of the spillway. Got the Palouse River flowing down through here, Cow Creek. Everything's so big you can't really pick it out, but that's where it is, trust me, okay? But here's this western or this eastern edge as we look up. And the water comes across and it's spilling through. This is what we call the Palouse Island. As I learned it, now it's called the Less Island. I don't care which one you use. This thing is 200 feet high. It's one remnant left of what was in this 100 square mile area that most of it got washed away. Down to the Pasco Basin, down to the Willamette Valley. I've talked to farmers down the Willamette Valley. Say, what's your soil like down there? And they say, oh, we've got about this much really good stuff. Well, that's just crap. Well, that really good stuff, I keep telling, well, bring it back, bring it back. We go over to the western edge and look down. I got a point up there, which I call North Point, because it's really distinct and you can find it really easily as you're driving around that area. But here we got water going down the western edge and cutting out the Palouse soil. We got to remember we also got water still going down Washtucna Coulee, Palouse River Valley, whatever you want to call it. And North Point is about 2 miles from the old Palouse River drainage. We're looking, it's north of us about 2 miles. That's how much has been taken out there. So we got a lot of water. But if that was granite that made up this rock, the water would have spilled across and it may have just gone back to its old course when we were done. Even the basalt there, it may have come across and nothing else would have happened. But something's going on here. Basalt is very hard, but it's also very brittle. And if you look here, we start seeing some pretty linear stuff there in the surface. Here's the east side, the west side, North Point is right there. And that's probably that one Palouse Island we were looking at right there. But you see all that linear stuff in there. And this had scientists puzzled. When I was in college 50 years ago, we learned all about the basalt columns and all this structural stuff in there. And then they saw this stuff and they did, they were kind of scratching their head. How do we get this? At that time, they thought, well, maybe we've got fracturing on a bigger scale. They don't believe that anymore. You look at this, I'm going to draw in some lines here. The blue line there, that upper part of the Palouse Canyon is 4 miles as straight as an arrow. And that's not very normal in nature. But you see there's Wind Lake Canyon and other canyons and HU Canyon at number 9. Then there's another direction that goes off, which I put in red. Another direction in green. And what they think is going on now is that after all these basalt floods came out, if you can imagine a layered cake, because all these layers going like this, then imagine that underneath all of that, we had some tectonic activity going on in the form of earthquakes. And this wouldn't be an earthquake where one side comes up and the other side goes down. This would be more like the San Andreas Fault, where one side slips along the other side. So just imagine, I've got this here and I've make this wonderful multi-layered cake. I've set it on top of here. And now I take this board and I go this way a little bit. What's going to happen to that cake? Well, the stuff on this side is going to stay put, and the stuff on this side wants to drag along with this side. And right above that, a crack forms. They've actually been able to do this in the lab, make a box with a movable bottom on one side. They fill it up with clay, pack it down nice and smooth. And guess what? If they hit that one side, right over that, a crack starts forming. And if they go a little bit further, they start getting cracks out to the side, just like the green and the red. You'll notice the angle between the blue and the red is the same angle as the blue and the green. So now they're pretty sure this is what they're thinking now, is that this is how this formed. And when you get that fracturing there, it's as if you went in there with a drill and drilled a whole bunch of holes and dynamited it. And they've taken all that brittle rock down to small pieces now. And when the water comes across, it's easy picking to clean that out. And I just found it kind of curious that the Palouse River course originally follows two of those same directions. I don't know if it's a coincidence or there's something to it. I don't know. We go up in the air and look down the upper Palouse Canyon. You can just see how straight that is. That's Little Palouse Falls, where the river changes. We're right over the Washtucna here looking south, east. If we fly down to the end of this and look up, we really start picking up those fracture lines in there. So here's Washtucna. Little Falls is right here. Washtucna's over here. And now we start getting these. I mean, they really show up.
Where's Lyons Ferry?
Lyons Ferry is behind us. We're going to go down in just a little bit here and see where that's at. We call these things fracture zones. And if we put in our directions, we got our blue direction in there, and we blow it through it. Our other lines here, you can kind of see them there. They more or less parallel that. And we got our green direction. And you'll notice that some of those actually go across and join up on the other side of the canyon. There's our other direction. It does the same thing. It crosses it. Even the Palouse Canyon, once it gets through that first stretch, it zigzags 3 times before going over the falls, and it follows those same fracture lines. So here we're looking down the lower Palouse Canyon. Snake River running left to right with Lyons Ferry down there. Some of you remember the Marmas Rock Shelter? At the time in the in the middle 60s, when they discovered him and dated him, he was the oldest human remains found in North America. Since then, they found others that are older. Little side story here. I've taken hikes from Lyons Ferry up to Palouse Falls before a number of times with our chapter and also with the Cheney Palouse chapter. How many have been on that hike here? Okay. On one of those trips, we had one young man that was just out of college probably, or close to it. And he was bound and determined to say that that was Marm's man, not Marmas man. And I could not get him to change his mind. I went to school with Gary Marmas, Randy Marmas, Linda Marmas. I rode on the same school bus for years and years. They were my neighbors. It's Marmas Man. No, it's Marms Man. Some people you just can't change. Anyway, and there's Palouse Falls State Park down there in Palouse Falls. This is Wind Lake Canyon coming in from the east, and that's kind of ends up being a hanging canyon there. But anyway, that's pretty cool stuff. If we go a little bit further to the west, we have the HU Canyon. If we go up here, we got North Point way up here, and now we're looking up. Well, we had been looking down before, but this is looking up the west side of this thing. A lot of you have been down to Palouse Falls, and you've come and you've gone down that winding road down to the canyon. There's a ranch down there. Pretty impressive, up and down. Well, right over here, you're missing the main part of the show. That lower part of the HU Canyon. That dry falls there is higher than Palouse Falls. It's over 200 feet. There's North Point. And there's that blue line. That line parallels the Palouse Canyon. We go up on the divide and we look over Long Lake Canyon. There's a deep lake, and I call that Deep Lake Canyon. And over there is Palouse Falls, and the Palouse Canyon's running right down through here. Blue Mountains off in the distance. These are fracture zones, okay? When that water is coming across the divide, at this point, that water is flowing this direction, perpendicular to Long Lake Canyon. We normally think of canyons as being eroded out by water flowing down them. It's not happening here. We've got this rock that's fractured in there, and as that water comes across 100 foot deep or more, it plucks that rock out of there because it's easy pickings. If we go down to the canyon itself, to the lake, you find that this canyon is symmetrical, not asymmetrical. You would think with all that water going over, there'd be more erosion down on the downslope side, but it stays symmetrical for the most part. So I call these things fracture canyons. It's not in any books I've read, but to me, it's the best description for them. Because it's not a coulee. It's not a canyon. As we think of a canyon with a river flowing down it, being formed by running water going down it, this is being just because the rock is fractured in the way it goes. We go down a little bit further. This is a road down Lyons Ferry, but here we've got this cut on this side, and then across the canyon here, you see it on the other side. See this other little feature that runs across here? Anybody know what that is? The Mullen Road. 2 stars for you. That is the Mullen Road. Do you know what other road it's called? There's another road that took some of the same road that the Mullen Road did, and that's the Colville Military Road that went from Fort Walla Walla to Fort Colville. They shared the same roads from Fort Walla Walla up to Cow Creek, where the Mullen Road went east through Benge, and the Colville Road more or less followed Cow Creek, went up the east side of Sprague Lake, got Sprague, and then more or less headed north. All this water is coming down to the confluence of the Palouse and the Snake River. So we've got water coming in out of the Palouse River right there. But we got to remember, it's not just coming down through the canyon at this point. We got that 10-mile wide strip across there. So we got water coming in over a wider area, all flowing into the Snake River here. And of course, a lot of that starts flowing down to Pasco, Tri-Cities. But there's so much water coming in here, probably a depth of 800 feet or more down at Lyons Ferry, that there's so much water there, it builds up and water starts flowing up the Snake River, backflowing. Clear to Lewiston, up the Clearwater a ways, and I've heard even gone up the river further and up the Grand Ronde Rivers away. Left off is this huge bar called the Mid-Canyon Bar. And if a lot of you have been on this road from here, you go down to Starbuck. If you ever go on that road, and got these grain elevators here, these huge elevators, but look right here, we've got giant ripple marks, actually through the whole bar. What they discovered is that there are a number of bars up the Snake River from here. And when deposits are made in a bar like this, we have what they call foreset bedding. So as the water comes down, it drops off sediment, then more sediment, sediment. So you end up with sediment that's downslope like that. Well, guess what? The bars upstream from here are all backwards. They're going the wrong direction. As that water flushed up there, it was depositing these things, and the foreset beddings are going the wrong direction. There's just pieces of evidence all over the place that scientists have discovered to show the magnitude of these floods. Water is also extending up, and there's another bar up here called the shoulder bar. It's not near as impressive, but what's impressive about it, it's 600 feet above the river level. I read one book that said that the earliest big floods actually came through here and went clear over the southern edge of the Snake River Valley there and came down through a little town called Clyde and down onto Eureka Flats, and some of those deposits there are actually from those first floods that came through. I mean, it's yeah. That was one written by, you probably got it back there. I'll have to look at it. Right down in Oregon. I'm 72 years old, so I can forget things.
Yeah, I can sympathize.
Yeah. Let's go down to Devil's Canyon. How many have been to Devil's Canyon? A few of you. Kahlotus is right over here. Here's the Snake River. Lower Monumental Dam is right here, and this is part of the structure that leads to the lock. So that's how close we are to it. Again, this parallels that upper part of the Palouse Canyon. Okay. What's interesting here, this is a lot shorter distance across, but we've got Palouse Hills up almost to the edge of it, unlike up above where there's, took out that wide swath. Well, why is this? There's actually drainages coming in from the side here that Bruce Bornstad has identified coming in over the hills here into the canyon. But again, if this is a fracture canyon and that rock is all loose, most people look at this, we've got a recessional waterfall here. We got this recession started down here and receded back, and there's actually a cataract right up here at the corner. I don't agree with that. I think this is all fractured rock. When that water came across, it just plucked it out really quick. Didn't have time to erode back to the sides and not enough water to do it. As you can probably know by now, understand, all of us, there's some real professional people in this audience tonight, and I'm probably going to be in trouble. But I've discovered that we don't always agree. Brett's didn't always agree with everybody. They didn't agree with him. I'm not Brett's. But I've always said that if you had a geologist, a geomorphologist, hydrologist, a botanist, and maybe some other scientists out there all looking at the same thing, they'd all be looking at it through colored glasses. And that's good, because we all see things a little bit different from our viewpoint. And when we bring those together, then we start kind of making sense out of what maybe is really going on out there. Okay. We're going to look at a couple more interesting things. Throughout the area, we have a feature we call potholes. This is this crater right up here. Okay. Washtucna Coulee is right below me. We're about halfway between Washtucna and the Palouse Canyon, Little Palouse Falls. There's another little feature right down there, a circular feature that we're going to look at too. So let's get up a little bit closer. There's North Point off in the distance again. So we got water running down this edge over the spillway. We got water running this way, continuing on down the canyon or down the coulee. Then we got this crater out here. This little guy just happens to be that size. So if you figure that out, that's over a football field in diameter. And you could put an 8-story building up there and the roof would be right at the ground level. I know that measurement because when that young lady was out here, she also had a young gentleman with him, and he was doing his work on potholes and measuring them. And so that, you know where some potholes? Yeah, I know where some potholes are. So they came down and stayed overnight with me, and then I took him out the next day to look at some of these potholes, and he had all the equipment to measure what was out there. So I'm not making this up. This is his actual measurements. The question still remains, how do these things form? And again, that's one thing that's probably still a little bit debatable. As Chad pointed out, there is a little bit of structure right here. There's a little bit of a crack right in there. So if possible, we had a little weak area there that got the thing going. We have a thing in these big floods, which we call kolks, K-O-L-K-S, and they're kind of like underwater tornadoes. And you've all seen air tornadoes that can lift up semis and houses and Toto and all this stuff, you know. We've got these water tornadoes that happen within these big floods, this circular going around. And the thought is that, like in some areas, these things go and they actually cut channels right above dry falls. There's a number of channels which they think were cut out by these things going through there. Here, we're close, you know, we're close to the Washtucna coulee here. So you've got water running down the coulee, and then you got other water going over the top. So you've got that chance to get the circular motion going, faster water and slower water, and you get that whirlpool action starting to go. I was watching a video on YouTube out of Scandinavia during the winter runoff. And out there in the water was this whirlpool in one spot going round and round and round and round and round. Pretty soon a big old log comes floating down and it gets caught in there and goes round and round. And then pretty soon it gets upended and whirlpool still going. No problem. A little bit later, an ice flow comes down. Big ice flow. Goes over this thing. You don't see the whirlpool anymore. You see all this ice flowing across it. Well, that thing isn't going to survive that. A minute later, the ice flow finally gets across it. It's still going in the same spot. So it kind of makes you start wondering if the same thing doesn't happen here. Once you get that thing going, it just keeps going. Other people thought there's a big rock in there that kind of gouges it out, but they never found the big rock. So I don't know. To be continued. There they are getting their measurements on that thing. I first discovered this thing on a topographic map. I'd walked by that thing probably within 30, 50 yards a number of times on my hikes out to Little Falls and missed it. But I looked on top of it, oh, those lines are going the wrong way. There must be a hole there. Sure enough, there was. But it takes a while. It's real easy to walk by it. This is that critter down below. We put a cow in there to give you some scale. Okay. And this is Washtucna coulee flowing right to left. And here we got the circular structure. How many people have heard of the Odessa craters? Okay. You've been out there. There's different theories about how those circular things formed. And there's a bunch of them over there by Odessa. I think it was Stradley that came up with the idea that when this basalt came out, it cools on top, and that's why it can keep flowing underneath, because it gets that insulating layer. But near the end of that, some of that flows on out and kind of leaves a void underneath, and then that settles down. And as it settles down, it cracks around the outer edge, and lava comes out and forms a dike, a circular dike. And you've got some of those like that over at Odessa. My thought is that here, the same thing happened, but instead of breaking around the outer edge, it broke in the middle as that went down, and then some new hot viscous lava came up and made that plug in the middle. It's the only one I've seen like this. I've had 3 geologists out there to look at this thing, and not one of them can tell me how it was done. Maybe some of you geologists here tonight might have some ideas. I would love to hear them. If we go the other side, between Little Falls and Hooper's that green mass over there in the distance. Here we've got another one. This one isn't quite as big. There's some people down right there, so I'm getting some idea. That's Palouse River coming down. What I noticed here after I got these pictures home and looked at them for a while, wait a second, what's this thing over here? Started scratching my head. And I started seeing this one. It's kind of, so I'm thinking these things formed during an earlier flood when this coulee wall was further over. And then as later floods came, and they came in and they started dissecting maybe this one's already been dissected nearly in half. And this one, it was getting really close to being dissected. I don't know. I just see things and think, well, that looks interesting. I wonder if that could be the case. That is the Palouse River. That's Hooper, and we're going to go right over onto this area next. There's some potholes over there, too. Not as big. But we also see all these other round things around here. So there's some stuff going on, which just tells us there's more mysteries to be discovered out on the Channel Scab. Yes, sir. A pothole is a round thing like we're looking at here. A cataract is a recessional waterfall. Okay. So we've gone through a lot of stuff here, and we've kind of skipped around the star of our show. So I think it's time to open the curtains on the star of our show. Palouse Falls is in the center of the divide there, center of the upper and lower Palouse Canyon. When I was growing up, we figured it was about 198, 200 feet high. But then a few years ago, this guy decided he was going to run a kayak over it. You've all seen the videos. Once he did that and did it right, they had to get an accurate measurement for the world record. And he ended up with, 184 feet. It varies depending on how much water is coming across the falls. But anyway. And of course, in the springtime, it rips and roars pretty good. This is the time of the year that most people go down to look at the falls, is in the spring when all the water is coming across. How many of you have been down there in the winter? One back there. Mm-hmm. I encourage you to wait until after the temperatures have been below freezing for about 2 weeks, then go take a trip. There's not very many people down there. I'm always surprised how many people there actually are. But it's a lot different view. In fact, the summer view, the fall view, they're all different, and they're all worthy of going down and taking a look at them. It's open during the winter, year-round. So as the sun sets in the west and evening falls upon us, I hope you've learned something new tonight and maybe piqued your interest to go take a look at things. I've got brochures here from our chapter, which you're welcome to help yourself to, which a lot of the features we have in our area were actually talked about tonight, between Big Cove and Little Cove and Palouse Falls and Staircase Rapids, Devil's Canyon. More information on there in the map. So you're welcome to take any of those. I also have the map that's put out by the National Park Service on the Ice Age floods. You're welcome to those as well. It gives a bigger picture. Also have some bookmarks if you're a reader and would like a bookmark. That's our chapter bookmark. So you're welcome to those as well.